Power. The average power generated by a force is the average rate at which work is done by that force. Whenever you think of the rate at which something is happening, you should think of it being related to the time that it takes. For example, the average rate at which work is done is just the amount of work done over the amount of time it is done over. Remember that work done by non-conservative forces on an object is equal to the change in mechanical energy of the object. That means that if we're dealing with a non-conservative force, the average power generated by the force is equal to the change in the mechanical energy of the object divided by the time interval. Remember also that when a constant net force is being applied to an object along the same line as the object's displacement, work equals the magnitude of the force multiplied by the magnitude of the displacement. So, in this case, the power generated by the force is equal to F times S divided by t. Displacement divided by time is equal to average velocity. So average power can also be written as the magnitude of the force times the magnitude of the velocity. These are some common expressions for average power that you might encounter and use when working problems. Since power is work over time, the units of power are joules per second. A joule per second is also called a watt. Let's look at an example problem. The lifting force from the vertical engine of my futuristic flying car does work on the car to accelerate it straight up from rest in my driveway to a speed of 5 meters per second in 3 seconds. During this time, the car has moved to a height of 7 meters above my driveway. The car has a mass of 910 kilograms. What is the average power generated by this lifting force? Okay, what are we given? My car starts in my driveway and is displaced to a height of 7 meters above the driveway. Let's assign up to be the positive direction, giving us a displacement of 7 meters. Our initial speed is 0, and our final speed is 5 meters per second. The time it took to reach this speed was 3 seconds. And finally, the mass of the car is 910 kilograms. Now what are we looking for? We're looking for the average power generated by the lifting force. So we need an equation for power. Here is one we just discussed. Average power equals force times displacement divided by time. We're given displacement and time in the problem, but we're not directly given force. How can we find force? Force should equal the mass times the acceleration. And how do we find the acceleration? Average acceleration is the change in velocity over time. The change in velocity is equal to the final velocity minus the initial velocity. So we substitute this change in velocity expression into the expression for acceleration, substitute this into the expression for force, and substitute this into the expression for average power to get an expression that contains our knowns and unknowns. Now we can plug in our known and unknown values, and using our calculator we get a value of 3.5 times 10 to the 3 watts for the power generated by this lifting force.